Hello everyone. In this tutorial, we will begin with lesson 3.1.3. The headline is evaluating function. What is evaluating function? Is finding the value of function at different points or quantities. Example number 1, if f of x equal to square root x plus 3, evaluate f of negative 2. Replace any x in the function with negative 2. Then it will be negative 2 plus 3 square root 1 equal 1. F of 6. Replace any x in the function with 6. 6 plus 3 equals square root 9 equal 3. F of negative 5. It will be square root negative 5 plus 3 equal to square root negative 2 and defined. F of x plus delta x. Replace any x in the function with x plus delta x. Then it will be x plus delta x plus 3. This is the value of x. Example number 2. If f of x equals 3 minus x square, evaluate f of 0. Then it will be f of 0, 3 minus 0 square equal to 3. F of square root 3 will be 3 minus square root 3 square equal to 3 minus 3 equal 0. F of negative 2, it will be 3 minus negative 2 square equal to 3 minus 4 equal to negative 1. F of t minus 1 will be 3 minus t minus 1 square equal to 3 minus, open this bracket, t square minus 2t plus 1. Simplify, 3 minus t square plus 2t minus 1 equal to t square plus 2t, 3 minus 1, 2 plus 2. It will be negative t square plus 2t, 3 minus 1, 2 plus. Example, if f of x equal cosine 2x, evaluate f of 0. F of 0 is cosine 2 times 0 equal to cosine 0 equal 1. F of negative pi over 4 equal to cosine 2 times negative pi over 4 equal to cosine negative pi over 2 equal to 0. F of negative 2, it will be cosine 2 times negative 2 equal to cosine negative 4 equal to cosine 4, since cosine is even function, equal to, from calculator you can find cosine 4. F of pi over 3 will be cosine 2 times pi over 3 equal to cosine 2 pi over 3. You can find it from calculator. I think it is negative 1/2. Example, if f of x equal to x power 3 minus x, evaluate f of x minus f of 1 over x minus 1. This quantity will be f of x, it is x power 3 minus x without any change, minus f of 1, 1 cube minus 1, 1 to the power 3 minus 1 over x minus 1 equal to x power 3 minus x, 1 minus 1, 0 over x minus 1. We can simplify this as analyze or factorize by x. It will be x power 2 minus 1 over x minus 1. Difference of 2 square, x minus 1, x plus 1 over x minus 1. X minus 1 reduced with x minus 1, then the answer will be x times x plus 1. Example, if f of x equal 1 over square root x minus 1, evaluate f of x. It is 1 over square root x minus 1 minus f of 2. It is 1 over square root 2 minus 1 over x minus 2. Simplify. 1 over square root x minus 1, 2 minus 1, 1 square root 1, 1 over 1, 1. It is minus 1 over x minus 2. Common denominator for the two fraction in the numerator, x minus 1 will be 1 minus square root x minus 1 over x minus 2 equal to 1 minus square root x minus 1 over x minus 2 times square root x minus 1. Example, piecewise function f of x equal to 2x plus 1 when x less than 0, 2x plus 2 when x greater than 0. Evaluate f of negative 1. Negative 1 belongs to this interval or this interval. It is less than 0. Then I'll substitute negative 1 in this function. 2 times negative 1 plus 1 equal to negative 2 plus 1 equal to negative 1. F of 0 belongs to this interval or this interval. It is here. X greater than or equal to 0. Then I substitute here in the second rule. 2 times 0 plus 2, it is equal to 2. F of 2, it's greater than or equal 0. Then it will be 2 times 2 plus 2 equal to 4 plus 2 equal to 6. F of t square plus 1. I don't know the value of t, but I know that t square plus 1, it is always greater than 1. So it is greater than 0. Then I'll substitute it here in the second rule. It will be 2 times t squared plus 1 plus 2 equal to t. 2t squared plus 2 plus 2 equal to 2t squared plus 4. Another example, f of x equal absolute value x plus 1 when x less than 1 minus x plus 1 when x greater than or equal to 1. Evaluate f of 0. 0 belongs to this interval since it is less than 1. Then I'll substitute here. Absolute value 0 plus 1 equal to 1. F of negative 3. Also negative 3 is less than 1. I substitute here in the first rule. Negative absolute value negative 3 plus 1 equal to 3 plus 1 equal to 4. F of 1, it is belong to this interval. It is where here x greater than or equal to 1. Then I substitute in the second rule. Negative 1 plus 1 equal to 0. F of 3, it is also greater than 1. I substitute here. In the second rule, negative 3 plus 1 equal to negative 2. B square plus 1, b square plus 1, it's always greater than 1. Then I'll substitute here in the second rule since here the interval is 1 to infinity. Then it will be negative b square plus 1 plus 1 equal to negative b square minus 1 plus 1 equal to negative b squared. Example, use the graph to solve this question. Graphically, number 1, find the domain and range of f and g. The domain, graphically, it's either whole x-axis from negative infinity to positive infinity, or a part of it that cover the graph of the function. Here we have the graph of the function of f start from negative 4 into negative 5, and the graph is continuous. There is no any cut or jumping in the graph. Then the domain of f is from negative 4 to 5. From negative 4 to 5 close interval. The domain of G goes without bound to negative infinity and goes without bound to positive infinity. Since it is not stopped, then the domain is open bracket from negative infinity to positive infinity. The range of f is either whole y-axis from negative infinity to positive infinity, or a part of it that cover the graph. Here, the part of y-axis cover the function f is from negative 4 to 2. Here. There is no graph of f up of 2 or down of negative 4. Then the range is from negative 4 with negative 4 to 2, since we have a circle here, a bold circle here. This is the range. For the g, the range of the function g, it's either all y-axis or the part that covered the graph. As we see, the graph starts from negative 4 up to infinity. Then the range is negative 4 closed from negative 4 to positive infinity open from the side of infinity. This is the domain and range graphically of these two graphs. Find x verifying f of x equal to g of x. We know that when we set f of x equal to g of x, this gives me the point of intersection of two functions. The point of intersection, as we see, it is 2 points only. Here, the value here of this point, the coordinate of x is x equal negative 2, and the x coordinate in this point is 3.5. Number 3, estimate the solution of g of x equals 0 and f of x equals 0. F of x equals 0. G of x equals 0 when the graph of g of x intersect with x-axis. Here, at this point, the coordinate is negative 3, 0, and in this point, coordinate is 3, 0. Then the value of x makes g of x equal 0 or x equal negative positive 3. For f of x, we have only just one point intersect f of x with x-axis. It is negative 1. the coordinate of this value is -1 by 0. Then here for g of x equals 0, here for f of x equals 0, the value is x equal -1. Number 4, find f of -2. This is -2, this is f of -2, it is -2. G of 3, g of 3, this is g of 3, it is 0. F of 1, this is 1, this is f of 1, it is 2. F of -4, f of -4 is 3. This is, sorry, g of -4 is 3. F of 0, this is 0, this is f of 0, it is 2. G of 0, this is 0, this is g of 0, 4. F of -5, as we see, the domain starts from -4, then f of -5 is undefined. Number 5, estimate a solution of f of x equal to. As we see, f of x equal to from 0 up to 5. Then all this value between 0 and 5, the evaluating of them is 2. Then x greater than 0 or equal than 0, less than or equal 5. Example, evaluate the function if you have this given table. F of 3, as you see, the value of f of 3 is 0. Then it is 0. F of 5, the value of 5 is 5. F of 0, we have no 0 here, then it is undefined. Estimate the solution of f of x equal 13. When the question asks you to estimate the solution, then you find the value of x, make the function 13, the value of x is 7. Example, if this table for the odd function, find f of -5. First, I'll make another table for this function, 2, 3, -5, -8. You know if the function is odd, when you change the sign of x-axis, the sign of y-axis also will be changed. Then f of 2 will be -16, f of 3 will be -9, f of -5 will be 1, f of -8 will be 3. F of -5, it is 1. F of 3 minus f of -8, f of 3 is -9, minus f of -8 is 3, it is equal to -12. Find k if f of 2k minus 1 equal 1. Where is the value of 1? Here. Then 2k minus 1 will be -5. Since the value of y is equal here, then the value of x should be equal to. Then 2x equal -5 plus 1 equal to -4. Then 2k. Then k equal to -4 over 2 equal to -2. For f of x equal 1 minus x squared, evaluate f of a over 2. Replace any x in the function with a over 2. 1 minus a over 2 square equal to 1 minus a square over 4. Common denominator for 4 minus a square. If f of b equal to b square plus 2, find f of b square plus 2, replace x in the function with b square plus 2. 1 minus b square plus 2 to the 2 equal to, open this bracket, 1 minus b power 4 plus 4b square plus 4 equal to 1 minus b power 4 minus 4b square minus 4 equal to 1 minus 4 is negative 3 minus b power 4 minus 4b square minus 3. It is the value of f of b square plus 2. Number 3, for the same function, find f of x plus delta x minus f of x over delta x equal to f of x plus delta x, it is 1 minus x plus delta x square minus f of x, it is 1 minus x square over delta x. Simplify this function. 1 minus, open this bracket, x power 2 plus 2x delta x plus delta x square minus 1 plus x square over delta x equal to 1 minus x square minus 2x delta x minus delta x square minus 1 plus x square minus x square with x square, 1 minus 1, 0. It will be minus 2x delta x minus delta x square over delta x. Factorize by delta x for the numerator, negative 2x minus delta x over delta x. Reduce delta x with delta x, it will be 2x minus delta x. Number 4, f of x plus 3 minus f of 3, it will be 1 minus x plus 3 power 2 minus f of 3, 1 minus 3 square, 9, equal to, open this bracket, 1 minus x power 2 plus 6x plus 9 minus 1 plus 9 equal to 1 minus x square minus 6x minus 9 minus 1 plus 9. 1 with 1, 9 with 9. Then the answer will be minus x power 2 minus 6x.